Hello, everyone. This is Elisa Baum. I am GridGain Systems Senior Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me. So I'm looking for hands up. I see them. Thank you. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. And in addition, I will send a link to the recording as well as the slides within 48 hours. So I'd like to thank you for attending today's webinar. It's called Achieving Continuous Machine and Deep Learning with Apache Ignite and TensorFlow. And it's being presented by Yuri Babak. He is GridGain Systems Head of Machine and Deep Learning Development. And then towards the end of the presentation, our Head of Product Management, Rob Meyer, will be taking questions from the audience. So with that said, I will turn the floor over to Yuri. Go ahead, Yuri.
Okay, thank you, Lisa. And again, hello, everyone. My name is Yuri Babak, and as Lisa already mentioned, I'm a head of machine learning and deep learning framework development at GridGain. Also, I'm Apache Ignite committer. And today we will speak about distributed machine and deep learning. So, in this webinar, I will provide some short introduction about distributed machine learning and about machine learning itself. Also, I will provide overview of Apache Ignite machine learning module, and I will speak how we could use TensorFlow with Apache Ignite for deep learning related tasks. And also I will show some short demo which will demonstrate how exactly we could perform machine learning and deep learning tasks. Okay, so let's start with a short machine learning introduction. I just want to be sure that we all on the same page, so I will reveal the meaning of some machine learning related terms. And I will start with raw data. This actually raw data, some kind of business data. It could be logs, it could be massive of transaction, it could be raw images, video, voice, text, documents, anything that we able to use for machine learning. The next term is train data and test data. The difference between those data is how we use this data. Basically, if we speak that we use training data, that means that we using this data for training our machine learning and deep learning model. And if we speak about test data, we speak about data which we're using for evaluate how good our models after training, but it's still basically the same data. The next main term is a training algorithm. It's the method how we could produce our model using our training set. And machine learning and deep learning model, it's just a formula for producing new data based on our business data. It could be a decision for fraud detection system. Is this transaction looks like fraud or not? Or it could be maybe answer for the question, what do we have on specific image? Is this the face of the man or no? Or if there's some specific face, for example. Also, we have meta algorithm. Meta algorithm is a combination of several models. We could combine our models in a really different way, and we have different approaches like boosting, bagging, stacking, etc. And after we have our model, we should evaluate it or validate it. It means that we have some set of metrics, and we will use our test data for validation our models, and we will receive the answer how our model good is our model good enough for us or not. Maybe we achieve the good quality and our model have precision like 99% or less, I don't know. And the last but not least is a model inference. When I will use term model inference, it means that we use a model for prediction, for example, in production system. So we have two main activities. We have model training, when we achieving specific formula for producing answers based on input data, and inference, where we using our train model for receiving prediction based on input. Okay. After that, I want to overview typical ML tasks. And it could be regression or time series regression. When we solve a task like that, we want to restore the law. For example, we have data about house pricing, and we want to restore the function that will describe how some specific features of this house will restore the law using this information, like number of floors, number of rooms, and we'll receive the answer we'll receive the answer which with value of this house, with its price. And when we speak about time series regression, that means that our data related have additional dependencies for time. Our data have additional time markers, so more advanced type of regression tasks. Also, we have a classification task. It could be binary classification or it could be multi-class classification. If it's binary classification, it's a single classifier that could answer yes or no. Is this transactional, fraud transactional, or not fraud? If it's multi-class transaction, if it multi-class classifier, its behavior could be more complex, and we able to build a more complex model. Also, we have clusterization tasks. This is unsupervised learning task when we don't know the right answers, and we want to analyze our data and split our data records to some kind of clusters. It could be ranking task, it could be entity extraction or structure recognition or pattern recognition when we analyze our data, and we want to get some structure from this data, but we don't know the specific fields, the specific structure, and we try to find out it. And generative models. So the last part of this machine learning introduction is the common scheme how we could use our machine learning algorithms in a distributed environment. Basically, we start with the model in initial state. After that, we want to calculate some local improvements. In that case, it's a gradient of loss function. This function shows how far answer of our model from the right answer. And our task is minimize those functions using the whole data that we store in our cluster. In that case, we just send some use map. In that case, we just use simple MapReduce scheme. We send some calculation task, and we compute local gradient on each node. And after that, we just aggregate it on reduce step and update our model in one node where we start our training. Basically, it's a really common scheme, and implementation of each algorithm depends, will be specific for each algorithm. And after this, I want to show how we actually could use all this knowledge in Apache Ignite. In Apache Ignite, we have an entity that calls Ignite partition-based dataset. Basically, it's internal API, and you will not face with it. But we should know the principle, how it works. We first of all, we have our data which stored in Apache Ignite cache, and in that place, I'm assuming that we all know what is Ignite, what is distributed cache, and how Ignite works with compute tasks. So we have our raw data that I mentioned before, and we want to use this raw data for distributed training. We define some information that calls learning environment. It's some stateless static information, really simple. The next part is more complex. It's a dataset context, and this context content of this context will be specific for each machine learning algorithm. And using this learning environment and dataset context, we can produce dataset data, which is recoverable and suitable for machine learning training. That approach allow us provide same guarantee for machine learning training as we have for all our Apache Ignite cluster. It means that we have fault tolerance, and if we lose some node during training, we can restore our state and continue from the last step. And we will not lose any data and any computation results. But should we think about computing distributed gradient, or should we think about internal APIs? Of course not. Our API is really easy and lightweight. So if we want to build and train and evaluate machine learning model using Apache Ignite, we can do it for 4 steps. The first one is define which algorithm we want to use. It's first line here, this one. We define that we want to use linear regression based on LSQR method. I will not explain how this method works because it's really irrelevant. Yeah. Now we define our trainer for machine learning model. Now we define how we will work with our dataset. And we define this vectorizer that really simple, maybe not so simple the first view, but it's really simple. Here we just use all features that we have and specify which column in dataset we want to use as label column. In that case, it's a first column. After that, during demo, I will show the easier example for this specific API. And the next step is just model training itself. It's just one simple one-liner that produce trained model using some data in data cache. So inside this trainer, we take Apache Ignite instance, we take our data cache, we take explanation how we should work with that cache, and we call all internal API inside this public method. So you don't need to think about all this complex matter. And the next step is just model evaluation. We define the data, we define which model we want to evaluate, we define how we want to extract our features, how we want to extract our labels, and we define a set of metrics. In that case, it's just one metric for now. So as you can see, this API is really simple. And what the next slide contains mostly the whole list of pre-built models that we already implement and all these models ready for use. As you can see, we have a bunch of implemented algorithms for each ML task. For example, we have several implementation of regression tasks. We have several classifiers. We have a couple of clusterizator. We have a bunch of preprocessing methods, and we able to work with meta algorithm. And this all for Apache Ignite itself, and I want to proceed to integration with TensorFlow. And first case, how we could use Apache Ignite with TensorFlow is using Apache Ignite as data source for TensorFlow. Usually, if we're working with TensorFlow, we write our code using Python. So it means that we should perform some migration. And in the slide, you will see that this migration is really simple. It's just one-liner. How we achieve it? We make some patches for TensorFlow and to make some patches for Apache Ignite, and now TensorFlow have native support of Apache Ignite, and it's only one case. Also, we could use Apache Ignite as storage for trained TensorFlow models, and use model trained pre-trained models which trained used TensorFlow. We also able to use the all TensorFlow tools for monitoring, like TensorBoard. The next case, it's a distributed training. Basically, inside this distributed training solve the same task. We just calculates a distributed gradient. How? But I want to provide some overview how it looks like on a high level. We provide specific tool that help to submit a TensorFlow code into cluster and manage it. Also, this tool will set up TensorFlow cluster and maintain it. In that case, we're able to provide the same guarantees for stability and fault tolerance for TensorFlow clusters as we provide for Apache Ignite. And how we could adopt our TensorFlow task that previously worked in a single node mode. The migration is also simple. Here we just should expand our configuration and add some additional lines. Here you can see the whole config for distributed training based on Apache Ignite. So if you want to train your models that already work in a single node configuration, you should, all that you need is just edit your config in your Python code, add this 4 lines, and it will work. So as I mentioned, the migration from single node deployment to cluster deployment with Apache Ignite is really easy. And we provide a complete cluster management tool, which called Ignite, tf.sh, that will deploy and maintain TensorFlow cluster on top of Apache Ignite cluster. And we will use the same benefits that we have from Apache Ignite cluster, like data collocation and fault tolerance that I already mentioned. And here I want to continue with a couple of demos. The first one is a demonstration of more advanced using of our Apache Ignite machine learning framework. Now I will stop my presentation and switch to my IDEA. Sorry. This example is part of a complete tutorial that we have inside Apache Ignite. This tutorial describes how we can work with all machine learning framework API. I already mentioned that I will show how vectorizer API is look like, and here it is. Inside our cache, we have an object with several fields, and we just specify which field we want to use for our training and which field in our object contain label. In that case, I'm using just a Titanic dataset. It's a really simple dataset, but our goal here is just show how we could use our API. So the first part is uploading the data, but usually I'm assuming that you already have your business data inside Apache Ignite cluster. So we define our vectorizer, and the next step is define splitter that will take our dataset and split it to two parts, to test dataset and to train dataset, which we'll use for model training and for model evaluation. After that, we will define a chain of preprocessor because in our Titanium dataset we contain not only numerical feature but text feature as well. We define imputer preprocessor that will fill all gaps inside our dataset. We define scalar preprocessor, we define normalization preprocessor, which will normalize our data. We define which model we want to train. In that case, it's a classifier based on decision trees, and we just run our training. As you can see, the input we use as input only Apache Ignite instance. We specify which cache we want to use for this training. We use our split iterator that provide set of case which we'll use as training set, and preprocessor which will apply for data before it will be used for before it will be used as training input. And after that, as we already saw, we see evaluation of model. And once again, we use this split that define a set of test keys that define a test set, the set of data which we will use for evaluation. We need it because we want to avoid overfitting. Overfitting, when a model overfitted, it means that our model can predict only the data that we used for training. And because we want to avoid it, for evaluation, we use the different data. And basically, that's all. I can run this process. It will take a couple of seconds for startup Apache Ignite node, and we actually done with that. We built our machine learning model based on decision tree. We evaluated and we calculate accuracy and test error, as you can see. Oh, something goes wrong. Oh. And the next demonstration is how we could call pre-train TensorFlow models from Apache Ignite. Of course, this example more complicated rather than previous one, but as I mentioned before, all this example is part of Apache Ignite source code, so all of you able to download it and try it by yourself. What do we have here? We have some pre-trained model and some data with some raw data with images, with labels. Basically, it's just a MNIST. MNIST is a popular data set. It's just a set of pictures. It's a handwriting digits. And we want to build classifier that will tell us which digit we write. So how we can infer this model inside Apache Ignite? First of all, we should import this model inside Apache Ignite. We define where this model located. We define how we will read this saved model. We load data from two files from MNIST, raw images and data with labels for all these images. And here we just use this pre-trained model inside Apache Ignite. I will start this example as well. As we can see, this example contains some mini benchmark that will show performance of model inference. And I want to pay your attention that we will infer model that train inside TensorFlow, and actual inference will be inside TensorFlow as well. So here we receive some information from TensorFlow. And receive the result of this benchmark. As we can see, for now, it's something about 700 pictures per second. And I want to pay your attention that it's just my laptop. It's not a real server node. It's not performance target hardware. So you able to achieve much better performance. And I think that this is all. So I put some links here where you will find additional information. Documentation about Apache Ignite, Apache Ignite source code, and documentation and source code about TensorFlow IO module, where we make our patches and where we have our Apache Ignite module. So I think that's all that I have for this webinar. So if you have any question, I will be glad to answer it. Yeah. So.
All right, so this is Rob Meyer. I have a few questions that have been coming up. First, there's a very specific question, which was data cache, is that part of Ignite? I think this was a term brought up at the beginning. And then I'll move on to the other questions.
Yes, when I speak about data caches, I mean caches inside Apache Ignite. We store all data in memory mode inside Apache Ignite cluster and use this data for model training and model inference for our pre-built algorithms, pre-built models, and for TensorFlow as well.
Mm-hmm. And then when you talked about on heap versus persistence, the on heap means it's in memory. It could be on heap or on heap, off heap in RAM, right?
Yes.
Okay. How does this compare to Spark's approach for machine learning and Spark ML? And how would you compare contrast? And how would you even use Spark ML with Ignite or Spark with Ignite for machine and deep learning?
I will start with deep learning. Actually, Spark, it's not about deep learning, it's more about classical ML algorithm. And if you speak about deep learning, basically usually we use some other frameworks or some other platforms like TensorFlow or Caffe or something else. And our main difference between Apache Ignite and Apache Spark is that we have native support of TensorFlow. It's part of our project and part of TensorFlow itself. But for Apache Spark, they don't have any official support. That's about deep learning case. If you speak about classical machine learning case, our approach in many places the same, but we already perform some benchmark, and when we develop our algorithm, of course we're looking on Apache Spark, and several of our algorithms much better because we use another algorithms, another way to implement and solve the same tasks. So
okay.
usually we have the same performance or maybe better in some places.
But with Spark, you do have to stream it all through, right? You're not running it in place as much.
Not sure that I understand the question correctly.
So with Spark, you have to at least prepare it as RDDs or prepare the data for pushing through Spark. So it is technically moving over the network at some point versus being partially co-located with the compute.
Yes, I already showed the scheme where we build our data set. In that scheme, we avoid any network data movements. So we don't move any data at least using the network. We just create local copies of our data on each node using data collocation. Because we have our learning context. I will return to this slide. Use it as illustration. Here we have our base cache, which we use for building our data set, and we have cache with dataset context. So we map partition 1 to 1, and for each partition we build our local data set and use the same principles for data collocation. So we don't build any analog of RDDs.
Yeah. No, I'm asking because I think if you're using large training data sets, it would take you about an hour to move 3.5 terabytes. So it can actually take significantly longer with Spark versus running it in place.
In our case, using our approach, we don't move any data.
Yep. Another question. How would you do this with .NET, for example, or C#? Is there any significant difference here?
Unfortunately, we do not focused on .NET support for ML framework.
Okay, so not yet.
Not yet.
Okay.
If we speak about support of other platforms, I already provide some some screenshots with Python code, and our goal, we focused on support of Python, because data scientists, people who use machine learning in production, they usually use Python.
So Python is coming.
Yes, Python is coming.
Okay. And then for importing and exporting different models, what would be your recommendation on if you were in this case, the model training and execution can be in the same framework. Let's say you actually have external models you want to import. A few questions would be, related questions are, what kinds of models can be imported and exported? And then related to that, what would you recommend, given your view into this, as your preferred models for using?
Okay, let's start with import-export. We focused on import but not export because we don't know if anybody will trying this use case when you train some model inside Apache Ignite and try to export it to some other platform. So we able to import model from other platform. Actually, it's as already mentioned, it's a TensorFlow, and I provide example how we can import this model and infer it inside Apache Ignite. Also, we have importer from XGBoost. It's a popular library for algorithm based on decision trees. And we have importer from Spark MLIP models. So we're able to import Spark models to Apache Ignite models and using it for continuous learning and online learning.
Okay. I think that's pretty much it in terms of the time we have for the questions. So Yuri, wanted to thank you. Plenty of good questions here. Wanted to thank you for going through machine and deep learning, and also going through some examples. If you folks want to reach us at any time, you can probably reach out to the Ignite community at ignite.apache.org and just ask away. There are a few links Yuri's showing where you can go find some information both in the Ignite docs and GitHub. Since there were some questions about GitHub, the link is here for where you can get Apache Ignite in general and TensorFlow IO models. Yuri, are there links for some of the examples as well? Where are those posted?
On Apache Ignite GitHub. So if you proceed to the second link, Apache Ignite sources, you will find example folders with complete set of Apache Ignite examples, not only machine learning, but all Apache Ignite examples. But any public API in machine learning framework covered by example. So we have examples for using each algorithm. We have example for using our model service. It's a special service where you can store your trained model and use it for further inference. And examples for all importers and for working with TensorFlow as well. And more information and documentation how you could use TensorFlow with Apache Ignite, anyone can find in third link.
Okay, perfect. Well, Yuri, I want to thank you for going through all this. If any of you are interested in more, there are actually some blogs on how all this gets done up on blog. I think it's blog.gridgain.com. You can always search for it. And we'll be posting more. We've started posting an ebook series up on gridgain.com as well to help people get started with different topics. If you're interested in finding out more face-to-face, we were actually at the Spark and AI Summit presenting on using Spark and Ignite together for some ML and DL. But we're also at the In-Memory Computing Summit, which we host each year, and we invite several vendors to come. So you'll find all kinds of information at that conference as well. If you go to the next slide, Yuri, I think we have some information about how you can sign up. We're doing June 3rd and 4th in London. If you're near London, come and join us. You can just sign up on imcsummit.org. And then in the Silicon Valley Bay Area in California, we'll be doing one in November. So feel free to come and sign up. And with that, I'd like to thank you for attending, and we'll talk to you soon. So thank you very much.